Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 6, 2025, about 7 days ago. The big idea is tangential amplifying guidance, a tiny inference module that boosts fidelity without extra denoiser calls, cutting FID on ImageNet with stable diffusion version 1.5, and DDIM at 50 steps from 76.94 to 67.81, while raising inception score from 14.79 to 16.49. The paper is titled TAG, Tangential Amplifying Guidance for Hallucination-Resistant Diffusion Sampling, and as we'll see later, the gains are both consistent and cheap to obtain. In short, the method amplifies tangential score components along the sampling trajectory, which theory links to higher probability regions, so it reduces hallucinations across models and samplers with minimal computation. Alright, Figure 1 contrasts unguided sampling with TAG, showing trajectories that either drift off distribution or bend toward high probability regions. Mode interpolation means the path cuts through low-density space between distinct data modes, which causes mismatched attributes. The left panel depicts no guidance, where the dash path wanders into out-of-distribution space. The middle panel shows the tag update that preserves the radial step and boosts the tangential part, so the path stays on manifold. The right panel highlights how this guidance steers samples towards semantically consistent regions while avoiding hallucination zones. So, Figure 1 showed tag bending trajectories toward high probability regions. Figure 2 shows that boosting the tangential direction extracts structure while suppressing noise. The tangential component means the part of the update that moves along the data manifold, which preserves semantics like shapes and layouts. The left grid compares the raw update, its normal part, and the tangential part, where the tangential rows retain clearer scene details. On the right, decoded snapshots at late and mid time steps look sharper when the tangential component is amplified, producing a more coherent final image. So Table 1 summarizes unconditional results and shows that tangential amplifying guidance reliably improves image quality at the same compute. The table reports that baseline DDIM has FID near 77. With tangential amplifying guidance at an amplification around 1.15, FID drops to about 68. Inception score also rises to roughly 17. The add-on pairs well with SAG, PAG, and SEG, which see further gains without extra denoiser calls. Alright. Table 4 compares conditional text guidance methods with and without tangential amplifying guidance on MS COCO. CTAG projects the guidance into the tangential subspace, meaning directions that move along the data manifold, which helps keep semantics consistent. The main message is that CTAG enables a 30-step sampler. That setting outperforms a 100-step classifier-free guidance baseline. FID drops for condition-only sampling, while CLIP score rises, and the same trend holds for PAG and SEG. Wrapping up, two takeaways stand out. Amplifying the tangential component steers trajectories toward higher probability regions, which cuts hallucinations without extra denoiser calls, and the same idea scales to text conditioning, where CTAG at 30 steps can beat a 100-step classifier-free guidance baseline. The broader implication is a simple, plug-in principle for on-manifold sampling across samplers and backbones. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.